Welcome to the Electromagnetic Spectrum Lab. Today you will learn about different kinds of electromagnetic radiation and their wavelengths and frequencies. When there is nothing in their way in a vacuum, all of these waves travel at the same speed of nearly 300 million meters per second, so we'd better get started if we want to catch up. This simulation uses voiceovers. If you don't have audio, click the speaker symbol on the top right of your lab pad to switch to play mode. If you disable the sound effects, the lab pad will slide up whenever there are instructions to read. You can select what type of audio you prefer. Deselecting any of the options will mute that option. Click Continue to learn how to navigate through your mission. Using the lab pad is an important way to get the most out of the simulation. Is this the first time you are playing a Labster simulation? Perfect! Then let's get started with your first mission. Find the lockers and open one of them. Find a lab code inside the lockers and pick it up. You look ready to start experimenting. Let's head into the main lab. Go to the electromagnetic spectrum workbench. The electromagnetic spectrum is a group of electromagnetic waves, ordered by their wavelength and frequency. The light that allows you to see this lab room is one type of electromagnetic radiation. Other electromagnetic waves have either longer or shorter wavelengths than visible light. Can you help me describe the uses and dangers for each type of electromagnetic radiation? Click on the computer screen to see an electromagnetic wave visually represented. Light waves are a type of electromagnetic wave. Named because they consist of both an electric and a magnetic component which oscillate perpendicular to one another. You can see the electric component in red and the magnetic component in blue. Electromagnetic waves are defined by their frequency and wavelength. You can also find this image and other images in the Media tab on the lab pad. Click on the right tab on the screen to view the entire electromagnetic spectrum. Which region of the electromagnetic spectrum has the highest frequency? You got that one right. Gamma radiation is the region with the highest frequency and as a result the shortest wavelength. Which sentence best describes the relationship between wavelength, frequency, energy and speed? You can view the image from the computer screen by clicking the View Image button. Well done! Shorter wavelengths have a higher frequency and energy. All wavelengths travel at the same speed, known as the speed of light. You can see that visible light occupies only a small section of the electromagnetic spectrum. Humans cannot detect most wavelengths, but you can definitely detect light if you are seeing this lab room. Which is the unique property of light within the group of electromagnetic waves? Definitely. All electromagnetic waves travel at the same speed in a vacuum despite their wide range of frequencies and wavelengths. However, only light waves with wavelengths between 390 nanometers and 700 nanometers can be detected by the human eye. Click on the light bulb to visualize light's wavelength. Light bulbs emit safe electromagnetic waves. Other wavelengths can be dangerous to you. Luckily, you are always safe from radiation in a virtual lab. Which is just as well, as I have been told I am radiant. Observe a few non-visible wavelengths by clicking on the other objects. X-rays and gamma rays have so much energy that when they interact with atoms, they can remove electrons. Because they take away the negative charge of the electron from a neutral atom, this causes the atom to become charged, or ionized. This type of radiation is called ionizing radiation. The ionization of atoms can change the structures of molecules. In the human body, this may cause damage to the organs or to the DNA. In a real lab, you would need protection from ionizing radiation, such as a layer of lead between you and the source. In a virtual lab, it is not only safe to handle sources of ionizing radiation, but we can also observe the wavelength. Ionizing radiation is a form of electromagnetic radiation that has high enough energy to remove which of theses from an atom? Well done! You know how to stay safe in this lab. Wonderful! Take a moment to observe the differences in their wavelengths. Can you order the objects from the longest wavelength on the left to shortest wavelength on the right? You can use the spectrum on the computer as reference. Order electromagnetic wave sources according to wavelength on the whiteboard. Did you think I would let you lift all these heavy items? Notice the Polaroid on your hand representing each of these items as soon as you click on them. Now place the Polaroids on the right order on the whiteboard in front of you. Fantastic job! Gamma rays have the shortest wavelengths and radio waves have the longest. Visible light is in between these two on the electromagnetic spectrum. Identify the objects that emit electromagnetic waves that are not dangerous to humans. Interact with the lab pad for more information. Roger that. Radio waves have the longest wavelength in the electromagnetic spectrum and are used for long-range communication. To send information, a radio transmitter oscillates to generate a radio wave. At the receiving end, the radio wave is transformed back into the original signal, such as sound or video. Not quite. X-ray waves are a form of ionizing radiation. Unlike visible light, X-rays can pass through the body. Because X-rays are absorbed at different rates by different tissues, X-ray detectors create images with shadows formed by bones, fat, muscle, etc. Used precisely and in higher doses, X-rays can also be used to kill tumor cells in cancer treatment. Oops! Gamma radiation has the highest energy on the electromagnetic spectrum and is a form of ionizing radiation. Because it can destroy cells, gamma radiation can be used to sterilize items such as food or medical equipment. It is also used in hospitals to treat cancer or to take images of the body, similar to X-rays. You had a light bulb moment there. Visible light allows us to see the world around us. Do you remember from the electromagnetic spectrum on the computer screen that we see different wavelengths of light as different colors? White light is actually a mixture of all of these colors together. You can learn more illuminating facts about light in the wave model of light simulation. Ding! Great job! Microwaves have a shorter wavelength than radio waves, but longer than visible light. Just like radio waves, they can be used for communication. In microwave ovens, water, fat and other substances in food absorb some of the energy and transform it into heat. One of the reasons X-rays and gamma rays can be dangerous is that exposure may lead to the development of tumors. How does exposure to ionizing radiation cause cancer? Well done. This is correct. Ionizing radiation can damage the DNA. Over time, errors in the DNA can cause cancer. X-rays and gamma rays may be dangerous, but they are also very useful. What are two applications of gamma radiation? No. This is incorrect. Please try again. Smart. Gamma radiation is used in hospital scans as it allows doctors to see inside the body. Because it causes damage to cells, it can also be used to destroy cancer cells or germs on food or medical equipment. Wow, you have learned a lot about the electromagnetic spectrum. I hope that you will come back to the lab to explore light and waves further another day. For now, thank you for helping me shed light on the electromagnetic spectrum and the uses and dangers of different types of radiation. Your score has been saved together with your 100% progress. Congratulations, you have completed the simulation. We hope you enjoyed it and you feel wiser now. Press exit to close the simulation. This will open a survey. Please take 1 minute to provide your feedback. It will help us to improve Labster. I gain relevant knowledge by using the simulation. I found this simulation motivating. I feel more confident about my lab skills after the simulation. I feel that I can apply what I have learned in the simulation to real-world cases. In general, I was pleased with the simulation. Thank you for your feedback. Please exit the lab by pressing escape. See you in another lab.